You've seen the images, right? Those massive islands of plastic trash just floating in the ocean. It's a huge, very visible problem. But what if the plastic we can see is only half the story? What if every single one of those water bottles is leaving behind an invisible chemical ghost? Today, we're going to dive beneath the surface and uncover the hidden footprint of plastic.
Okay, get this. Every single year, the world produces over 70 million tons of PET plastic. To try and wrap your head around that, that's the weight of something like 10 million elephants. This is the stuff that makes our water bottles, our soda bottles, even the fibers in our clothes. It is just a truly mind-boggling amount of material. Now you might think, okay, but we recycle, right? Well, the tough reality is only a tiny fraction of that. We're talking somewhere between 10 and 28% actually gets recycled. So what about the vast majority? It's just discarded. It ends up in landfills, or, you guessed it, makes its way into our rivers and oceans.
We usually focus on the big stuff, the plastic pieces we can physically see. But here's the thing. When that bottle is floating in the ocean, getting battered by waves and baked by the sun, it doesn't just break into smaller and smaller pieces. It actually starts to dissolve, breaking down into a kind of chemical soup. The big question is, what exactly is in that soup?
The main culprit here is a process called photodegradation. And you can think of it like this. The UV radiation from the sun acts like a pair of microscopic molecular scissors. These scissors just snip away at the long, super strong chemical chains that make plastic so durable, and over time, they cut the plastic down into these tiny little compounds that can actually dissolve in water, basically leaching a chemical footprint into the environment.
So how in the world do you study this? I mean, this process takes years, maybe even decades out in the real world. Well, scientists came up with a pretty brilliant way to speed things up by essentially creating a tiny ocean right there in their lab.
And that really is the key challenge, isn't it? If you're studying long-term environmental impact, you can't just toss a bottle in the ocean and wait for 20 years. You've got to find a way to accelerate time so you can see the future now.
And the method they came up with is actually pretty straightforward. Researchers took regular, off-the-shelf PET water bottles and just cut them up into little squares. Then they put these plastic bits into some artificial seawater, and then they just blasted them with a high-intensity UV lamp. After that, all they had to do was analyze the water to see what chemicals had leached out.
And here is the really ingenious part. The scientists calculated the exact intensity they needed for their UV lamp so that just 13 days in the lab would be the same as an entire year's worth of sun exposure in the real world. So a whole year of aging compressed into less than 2 weeks. Pretty clever.
So, with the experiment done, it was time to look at the results. What did they actually find in the water? What is the secret chemical fingerprint that PET plastic is leaving behind? They found 17 totally distinct chemical compounds that had leached directly from the plastic into the water, all created by that UV light breakdown.
And this chemical cocktail was a mix of different things. Some of the chemicals, like terephthalic acid, are actually the basic building blocks of the plastic itself. It's like the plastic is literally dissolving back into its core ingredients. But they also found other things, like dibutyl phthalate, which are additives, basically chemicals that are mixed in during manufacturing to make the plastic flexible.
Now, to be absolutely sure that the sun was the trigger, they ran a control experiment. They did the exact same setup, same plastic, same artificial seawater, but this time they kept it in total darkness. The result? Basically no chemical leakage at all. And that confirmed it. The UV light is what kicks this whole process off.
Okay, so we know this happens in a lab, but a lab is a super controlled environment. The real question is, can we find this exact same chemical fingerprint out there in the wild?
And really, this is the million-dollar question for any environmental scientist. Does what you find in the lab actually translate to reality? To find out, the researchers had to, well, get their boots wet and head out to the coast.
They traveled to Ganggu Port in South Korea, which is a busy area, lots of tourism, fishing, agriculture. They took sediment samples from 10 different spots, and they were looking for the very same chemical compounds they had just identified back in their lab.
And they found them. 5 of the key chemicals from their lab experiment showed up in the real-world sediment. Not only that, they were found across all 10 sites, and often they found 2 or more of these chemicals together, which is a huge clue that they all came from the same source, degrading PET plastic. This was the smoking gun. This isn't just a lab curiosity, it's happening right now in our oceans.
So finding these chemicals is one thing, but now we have to ask the really big so what questions.
How much of this chemical soup is actually out there? And is it dangerous?
Well, based on their lab results and estimates of how much PET plastic gets into the ocean every year, the researchers calculated a staggering figure. Somewhere between 1 and 5.5 tons of these newly identified compounds are potentially being released into the world's oceans. That's like dumping the weight of a car full of these chemicals into the ocean every single year.
That is a huge amount of chemical pollution, but, it only really matters if those chemicals are toxic. So for the final piece of the puzzle, the team had to figure out the risk.
So using toxicology models, they checked out the compounds they found, and the results were pretty concerning. 2 of the key chemicals, that plasticizer dibutyl phthalate and the polymer building block, terephthalic acid, were both classified as chronic too. Now what that means is that they are officially considered toxic to aquatic life. We're not talking about something that causes immediate death, but something that has the potential to cause serious, long-term harm to their health and their ability to reproduce.
The real danger, as the researchers put it themselves, is accumulation. They warn that as these chemical products build up in the environment over time, they could have these chronic, harmful effects on marine life, especially fish, and that could potentially disrupt entire ecosystems.
And that kind of leaves us with a final sobering thought. We are trying to fight a war against the plastic that we can see, the bags, the bottles, all the packaging. But what this research shows us is that there's a second, invisible front to this war. A chemical war being waged in our oceans, one dissolved water bottle at a time. We sort of have a plan for the war we can see, but what's our plan for the one we can't?